Welcome to our first video lesson together. We're going to be talking about slope. Slope has the symbol of M. I don't know why. I always talk about it though, it's because it's the way the line moves. So M stands for move. Okay. Slope is the rate of change from one data point to the next, how fast the graph increases or decreases. There are 4 types of slope, and you've got visuals there that you can look at, but I'm going to play you a little video that shows you about slope, the 4 different types.
Welcome to the adventure of Slope Dude. Meet Slope Dude. He loves to ski. We are going to follow him and he'll teach us some important habits. This is the course he's skiing today. Again, what he says will teach us about slope. You need to remember that Slope Dude always skis toward the right or eastward. When he starts out, he's going uphill. It's hard work. He says puff, puff, positive as he goes up the mountainside. Puff, puff, positive. Puff, puff, positive. Puff, puff, positive. Now he's at the top. It was puff, puff, positive all the way up the mountain. But now he can look forward to the downhill. On the way down the mountain, he says, nice, negative. Nice, negative. And now, after the downhill, he's in for the hardest part of the ski run, the long, flat part. He says, this is zero fun. This is zero fun. This is zero fun. This is zero fun. And as he finishes the flat part, he doesn't see well ahead, and all of a sudden, he comes to the edge of a cliff. It's straight down. So frightened is he that he says the worst curse word possible in math and in algebra. Undefined. This has been the adventure of Slope Dude. Remember always what he said during a ski trip. Up the hill or up the slope, he said, puff, puff, positive. On his downhill run, he said, nice, negative. On the long, flat part of the course, he said, this is zero fun. And finally, when he went over the vertical cliff and went straight down, he yelled the worst curse word of math and algebra. Undefined! The uphill is a slope with a positive number. The downhill is a slope with a negative number. The flat part is a slope of 0. And the straight up and down or vertical part is undefined. This has been the adventure of Slope Dude. Thanks for viewing.
So hopefully you've got a good idea now of the different types of slope. Positive, the line is going up from left to right. Negative slope, the line is going down from left to right. Zero slope is a horizontal line, represented here by the line y equals 2. And undefined slope is a vertical line, which is, hopefully you can see it right here, x equals 2. Vertical line as undefined slope. Okay, so there are 2 or more ways that you can figure out slope. Okay, one of the ways that's quite popular is using the slope formula, where you get the coordinates of 2 points, and you can do that from a set of ordered pairs, a graph, or a table, and then you insert them into the formula. The y values go in the on top, the x values go on the bottom. And formula that you may come across in your travels through algebra is another formula called, where we write it this way. It means exactly the same thing. We say the change in y over the change in x. Okay. This is an equivalent formula. The change in y, y2 minus y1, right? We went from y2 to y1. The change in x, we went from x2 to x1. All right, let's see some applications of these lovely formulas. So, first off, what is the rate of change of line K? All right, so here's line K, and we can go anywhere we want to on the line. I like to look for places where it's going through the corner of the box. So here and here are nice points. Okay, now I can use the slope formula, but when I have a graph, I tend to use a counting method when they're really close together like this. So I would just simply count how far am I changing on the y-axis. So that's 1, 2, 3. And how far am I changing on my x-axis? In this case, 2. So my slope would be 3 over 2, and then I have to identify, is it positive or negative? Well, I'm looking, my line is going down from left to right, so it is negative. Okay, we're going to approach line N similarly. Here it's going through the corner here at the coordinate 4, 6. And it appears to be going through the corner again here at 3, 1. So I can count it again, or I can use my slope formula. I like to change things up. So we're going to use our slope formula, which says the change in y's, so 6 to 1. So we went from 6 to 1, and then we went from 4 to 3 on our x's, which is 5 over 1, or simply 5. Okay, let's see if it works out. Let's see, 1, 2, 3, 4, 5, and 1, 5 over 1, and it is a positive slope, so that's it. That's our answer. All right, let's look here at line W. Line W is a little bit difficult to see, but you can kind of find it because of the arrows here, right? Okay, so line W is going straight across. Now, we were told in the by Slope Dude that this would be 0 fun, so we already know that it's 0. But I can actually figure that out, because if I take my 2 points and I count how much did my y change. Well, my y didn't change at all. I didn't go up, so my y change, right? My change in y is 0. Okay? And then if I look at my change in x at the same time, I went over 1. So 0 divided by 1 is simply 0. So if I don't remember that the slope of a horizontal line is 0, I can still figure it out. Okay, and then finally line P. So I'm assuming that's that vertical there. Yep, it sure is. There's line P. Okay, so again, I can pick 2 points on the line. And if we take our approach again, the change in y, well, it's changing 1, right? 1. And then the change in x, well, I didn't go anywhere. I didn't change x value, so that's 0. And this is a little tricky, because you think, oh, well, it's got a slope. It's 1 over 0. But you can't divide by 0. It's not allowed. So that is why we say that it is undefined. All right, let's look at some more examples. Which of the following tables best represents a linear function with a rate of 3 over 2? Okay, so a linear function is a function that makes a line, such as Manuel and spending his earnings, or Susan saving her birthday gift, or even the lines that we created when we walked away and towards the motion detector. So all of those were linear functions. So we're looking for a rate of change of 3 over 2. Now with tables, we should be able to pick any 2 points and calculate our rate of change, or our slope. So we look here, and I don't like negative numbers that much. Shh, don't tell them. Okay, so I'm going to start here with the positives, and that we had a change from 7 to 9. So we increased by 2. And over on this side, we increased by 2. So that's a rate of change of 2 over 2, which is not what I'm looking for. I was looking for 3 over 2. Okay, so it can't be F. So then I go to G. And again, I'm going to choose positive numbers. We're increasing here. From 1 to 3 is 2. From 6 to 10 is an increase of 4. Not what I was looking for. Okay, so I go to the next one. We're increasing 3 here. and we're increasing 2 here. So that gives me the 3/2 that I was looking for. So I think my answer would be H. Okay. Now we can just verify here. We have a change of 2 and a change of 3. Okay. So be careful on that because that's 2/3 as opposed to 3/2. Okay. All right. Let's check out another example. What is the slope of the line that contains the points 2, 0, 0, 3, and 4 and -3? All right, now they give you a graph here, and the reason they do that is because you could graph the points and count the slope, like I showed you earlier, or you can ignore the graph altogether and calculate your slope by hand. I'm going to show you both ways so you get to choose. All right, so 2, 0 would be located here. 0, 3 is right there, and then 4, -3, 1, 2, 3 is located right there. Okay, so if I count my slope from point to point, so my change in y, 1, 2, 3, and my change in x, 1, 2. Okay. Now, I chose to count down and to the right, but I totally could have counted up and to the left. Direction isn't so important as long as you remember it's your change in y and your change in x, and you go the same direction the whole time. So you can't like go down and then choose to go over. That'll mess you up. Okay, so if we started here, we could go up 1, 2, 3, and then we could go to the left 1, 2. Either way, we have a slope of 3/2, and then the line that would be going through these points would be going down, so we have a -3/2 slope. All right, now that is a lot of drawing and counting, so for those of you who like a little more efficiency, you can just pick any 2 of those points and you can calculate slope. So I'm going to choose these 2 points because zeros usually make things easier. We don't have to do that much arithmetic that way. All right, so our change in y, right, would be 0 to 3. So we're going from 0 to 3. And our change in x would be from 2 to 0, which gives us -3 over +2, which is what we found by counting. So you can see which one you like better and you use that form. Let's look at question 4. If 3b, b and 4b, 5b are 2 points on the graph of a line and b is not equal to 0, what is the slope of the line? Now this looks really complicated, okay? But all they're saying is there's some point where we've had some number b that we're multiplying all of our points by, all of our coefficients, sorry. So 3, 1, 4, and 5 are all getting multiplied by the same number. Okay? And that b is not equal to 0, because then that would make all our points 0, 0, which would just be the origin. All right. So what is the slope of the line? So for this one, we can actually graph those points like we did up above because we don't know what b is. So this, we're going to go with our formula, and we're going to subtract our y's, and we're going to subtract our x's. We're going to say we've got the change in y's. So we went from b to 5b, and we went from 3b to 4b. Okay, so I understand that there is a 1 in front of that b. So 1 take away 5 is -4. And 3 take away 4 is -1. So I simplify this. -4 is divisible by -1. So that's actually a slope of 4. Oh yeah, I forgot to put the b's on there, right? Okay. Sorry about that. I got ahead of myself. You see, it would be negative 4b and negative 1b, but if you have a number in the numerator and the same number in the denominator, you're actually dividing b by b. Well, b divided by b is 1. So 4 times 1, 1 times 1, it's still just negative 4 over 1, which still is just 4. Okay, you should now be ready to work on Slope Day 1 worksheet.